All right, ladies and gentlemen, so today we are going to be talking about, I think it should say lesson 7 here. Let me actually change that real quick. Lesson 7, Rational Roots Theorem. You guys' homework's 3-7. But we're going to be talking about the Rational Roots Theorem today. So we're going to start off this lesson. You guys are going to do this warm up here. So you're going to be given this, you're going to evaluate f of 4, and then you are going to be asked to factor this. So on the next page, you're going to have to rewrite it in factored form. So you're going to have to divide out one of the factors and go on from there. And then list the zeros that you find. So that's going to be for you guys to warm up. It's like a little review. So give it a shot. I will be including the completed notes on Google Classroom, so you can check it there. Check your work after you're done. All right, but today our real topic is called the Rational Roots Theorem. So if you have a polynomial that's in just the form that we usually see it, like, you know, it's got something x squared plus something x cubed plus, or some x squared cubed, some x squared, some x, some constant, like, and it just goes down like that, and it has integer coefficients, then every rational zero of the function has the following form. So I just need to grab my pen here. All right. So what it's going to look like is your PRR. You'll see me write this a lot today because I don't feel like writing out possible rational roots. Since I don't feel like writing that out every single time, I'll just write PRR. So our possible rational roots, we can find what our possible roots are. Now, these aren't exactly what our roots are. It just gives us a list of possibilities of what our roots could be. And we can find that by finding the factors of the constant and then divide that by the factors of the leading coefficient. Which is just the number, the coefficient in front of the first term. And this will give us our possible list of rational roots. Sometimes this list will be very long, sometimes it'll be short. Just depends on what our polynomial is. So let's give it a shot here with this first one here. So for this one, it says list the possible rational roots of each polynomial functions. So looking at this guy here, something that we need to actually, I guess, say here is that the number of roots that this is going to have is 3. Okay, so this is the number of roots. We can tell because it's a third degree polynomial. So the highest exponent on the polynomial is the number of roots it'll have. Okay, now they may be real roots or they may be imaginary roots. We'll talk about that at a later time, but 3 right now is kind of like the number of roots we're going to have. But I just wanted to bring that up now, but we'll talk about it later. So the first thing we need to do is come up with our factors of the constant. So which of these numbers in this expression are the constant? Well, it's the one that's not going to change based on the variable. So in this case, we are going to have -4 as our constant. So what are the factors of -4? Well, you have 1 and 4, and then you also have 2 and 2, right? So those are your factors. So the possible rational roots here for this first one are plus and minus 1, plus and minus 2, or plus or minus 4. Okay, so those are the factors of the constant. Then we got to look for the factors of the leading coefficient, and that's the leading coefficient here is going to be 3. It's going to be all over. What are the factors of 3? That's right, it only has 2 is just 1 and 3. So it's going to be plus or minus 1 and plus or minus 3. Okay, so what that means is that our rational roots could be any combination of the above numbers and the below numbers. Okay, so it could be, so for example, our possible rational roots could be 1 divided by 1 is just 1. So we could have plus or minus 1. 2 divided by 1 is 2. So we could have plus or minus 2. 4 divided by 1 is 4. Plus or minus 4. And then we do the same thing with 3. So 1 divided by 3. So it could be plus or minus a third. It could be plus or minus 2 over 3, or it could be plus or minus 4 over 3. Okay, so these are all of my possible rational roots. So how many numbers is that? So let's see, that's 1, 2, 3, 4, 5, 6, 6, but you could also include the negatives there. So that's going to be 12 options for your possible rational roots. That's a lot of options. So we are going to, so typically when you're doing these, I would try like 1 and 2 first and kind of like look at the problem and figure out which of these could be one of my roots. All right, so let's do this one. We can do this one real quick. So the possible rational roots, what am I doing? Possible rational roots for this. It's going to be, we're going to draw a little thing. Red, the factors of the constant. So we got 6, so that could be 1 and 6. It could be 2 and 3. And then I think that's it, right? Yeah. So it's going to be 1 plus or minus 1 plus or minus 2 plus or minus 3 or plus or minus 6. Okay. And then for the leading coefficient, it's to the degree of 2. So on bottom, we're just going to have plus or minus 1 and plus or minus 2. So let's figure out any combination of these. So the possible rational roots are, let's say we have plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. Now we're going to go on to the denominator of 2. So we're going to have plus or minus 1/2. I'm not going to write in here. So I'm not going to write in here plus or minus 2 over 2 because that'd be the same thing as 1, right? So I'm going to skip that one and then do plus or minus 3 over 2. And then again, I'm not going to rewrite 3. So I'm just going to keep 6 over 2 as that. And there you go. These are your possible rational roots. So I guess the thing I wanted to point out with this example as compared to this one is you don't repeat the roots. So if I have plus or minus 2 over 2, there's no reason to write that because you already have plus or minus 1. Okay, great. So that's the possible rational roots, the rational roots theorem. Now this is going to be helpful because now we aren't going to be given a root right off the bat like we were given a root. You'll find out that when you plug this in, you get 0. So you're given a root right off the bat. For this one, we're not going to be given any roots. So find all the roots of the polynomial function that and sketch a graph. Okay, not that bad. So let's figure out what our possible rational roots are for this one. So possible rational roots, to start, we're going to put -2. So what are the factors of 2? It is going to be 1 and 2. Not too bad. So up top, we got plus or minus 1 and plus or minus 2. On bottom, the leading coefficient here is 1. So it's just going to be plus or minus 1. Great. That helps us out a lot because we don't have a lot of combinations here. Our possible rational roots are just plus or minus 1 or plus or minus 2. Okay. When I look at this problem here, I can kind of already start to like think about which one of my roots are going to work. There's two ways you can figure, like two ways that you can look at this. You can either take 1 and 2 and plug it into the equation and see if you get 0. You can do that, or you can do synthetic division. So I'm going to do synthetic division. What number do you guys think I should do? We don't know. I'm going to pick 1. So I'm going to say 1, and if 1 is a root, then it'll divide perfectly into this. So I'm going to set this up. All right, so let's do this. So bring down the 1. 1 times 1 is 1, so this is 2. 1 times 2 is 2, so that's that. So this will be 0, and then 0 times 1 is 0, so I got -2. Uh-oh, that's not good. My remainder here is -2. So that means that this is bad. That means that this is not a root. Not a root. So that means that we need to pick a different number. So I don't want +1. Let's try -1. Maybe that'll work. So I got 1, 1, -2, and -2. Let's plug this in. So bring this down. We got 1. 1 times 1 is -1. This is 0. This will be 0. So I got -2. That times that is +2. So we got 0. Oh, check that out. Our remainder is 0. That's awesome. That means that this is a root. Great. So -1. So -1 is a root. Oh, whoops. Root. It's a 0. It works out. That's awesome. So, and we kind of already did it, right? So we took this. Hey, check that out. That's going to be one of our answers. So f of x is equal to x plus 1. That's one of our answers. And then, hey, look at that. We already actually synthetically divided it. So we can rewrite this out. This is going to be x squared plus 0x, but I don't want to write that, minus 2. So I'm going to have x squared minus 2 for my other factor. Okay, cool. So now I'm going to find the other root. So we know one of my zeros is already -1. That one was easy to find. Now this one might not be so obvious. When we're looking for the roots, remember, we're trying to figure out what I can plug in for x to make this thing equal 0, right? So I set it equal to 0, and now I'm just going to solve it. So I'll have x squared is equal to 2. How do I get rid of that squared? That's right, I square root both sides, and I get x is equal to plus or minus square root of 2. So I have 3 roots. I have 1 right here, and I have 2 right here. Great. So let's get your graph. So first off, leading coefficient is positive, and it is an odd thing, so it is going to be rising on the right side. It's odd, so they're going to have opposite directions. Remember, odds playing disco, and our y-intercept is -2, so I'm just going to go 1, 2, got a y-intercept right there. We're going to go -1, 2, +1, 2. -1 is going to be right about here. And then -√2, which is that, it's going to be like 1.4 something. So I'm going to put it right here. And then +√2 is going to be over there somewhere. So this is √2 right here. This is -1. Oh, it's -√2. This is +√2. That's -2. All right, so let's graph this function. So it's going to be going up. It's going to go through this point, curve, go through that point, come back down here, and go through that point. And we have our function. Okay. So to reiterate, the possible rational roots just kind of narrows it down and gives us a place to start. We have to actually go trial and error until we find out whether one's a root, and then we can simplify the expression and graph from there. Let's try another problem. Let's Let's try another problem. So here we go. Let's find the possible rational roots of this one. So starting off for this one here, so we're going to take our constant term, and that is going to be going on the top. So we got plus or minus 1, comma, plus or minus 2. And then on bottom, then we have factors of 3, which are plus or minus 1, plus or minus 3. Now, keep in mind for this one, we have an exponent of 4 on that leading coefficient there, right? So we have this exponent of 4, which means there are going to be 4 roots. So we should keep our eyes open for 4 different roots. Okay, let's do it. So our possible roots are going to be plus or minus 1, plus or minus 2, plus or minus a third, and plus or minus 2/3. Okay, I know right off the bat I don't want to mess with these, so let's try -1 again. So let's see what happens. So we got -1. We're going to synthetic divide this into this. So let's see, we got 3, we got 11, we got 11, we got 1, we got -2. So let's synthetic divide. 3, -3, that's 7, -7, that is 4, that's going to be -4, that's going to be negative, oh wait, did I add that right? Oh, did I mess something up? Oh, I did mess something up. I was like looking at this, and I would have gotten, so that would have been -3, and then this would have been +3, and then I had a 1 here. So this remainder is not 0. So you got to really be careful, right? So remainder here is not 0, which would make me think that this is not a root typically, but I just made a mistake. And the mistake I made is this isn't 7. This is actually 8, right? So that means I got to do it over. So I'm going to erase this, erase that, erase this, erase that. Okay. Well, let's continue on. So we got -8. So then this is going to be 8, 9, 10, 11. So that's 3. It's going to be -3. Let's get it's 2, -2. And then this would be +2. We multiply those and we get 0. Hey, look at that. So now we got a remainder of 0, which means that -1 works. So let's write out the factored form real quick. So I'm going to have my first factor of x plus 1, which I got because my root is -1, right? So I take that and plug it down right there. And then all of this stuff is going to be my the rest of my stuff. So it's going to be 3x to the power of 3 plus 8x squared plus 3x minus 2. Okay, so looking at this, it looks like this stuff needs to be broken down a little bit more. Okay, so we need to factor that a little bit more. All right, so we can do it again. So let's see, what could I, let's see here. I'm going to, just because I know what's coming, I'm gonna try -1 again. Because if we look, we still have a 3 as our leading coefficient, which we had up here, and we still have a 2 as our constant. So our possible rational roots don't change. They're going to be the same. So we got 3, 8, 3, -2. Let's try this. So that's going to be 3. We've got -3 here then. That's going to be 5. -1 times 5, -5. That's going to be -2. Multiply these two, I get +2. Hey, check that out. I got 0 again. All right. So that's my remainder my remainder is 0. So that means that this is also another root. So I'm going to keep writing this. So I'll have f of x is equal to x plus 1 from above here. And then also this is another one of our roots. So we can simplify that as another x plus 1. And then we'll copy down this answer. So it'll be 3x squared plus 5x minus 2. Man, that's a lot. So now we just need to solve this. So now we just need to figure out, now we just need to factor this guy. So I need to figure out what two numbers multiply to get -6 and add to get to 5. So what two numbers multiply to get this -6 and add to get to 5? Well, I'm thinking that in order to do that, we are going to have 6 and -1. 6 times -1 is going to give me -6. 6 times, or sorry, 6 plus -1 is going to give me 5. So I'm going to have x plus 1. All this stuff is rewritten. I'm going to rewrite this as 3x squared plus 6x minus 1x minus 2. And then we just factor it by grouping. So our first group is this, and our second group is this. So out of the first group, what's the common factor between 3x squared and 6x? That's going to be 3x. And then I'll be left with x plus 2. And then in the green, we're going to factor out a -1, and that'll leave us with x plus 2. All this is just repeated. All right, and then when we finally get to the end here, we are going to have x plus 1 times x plus 1 times 3x minus 1 times x plus 2. So you'll notice here we have a double root, and that means something when we go to graph it, right? The multiplicity of that root is 2. So when we graph it, that's going to bounce off at the x-intercept. Speaking of graphing, let's graph it now. So here the x-intercept is going to be -2. Here the x-intercept, we have to set this equal to 0. Add 1 to both sides. You're going to have 3x is equal to 1. And then that means x is equal to 1/3. And then here for this one, plug in -1. So our x-intercepts are -2. So -2. We have one at -1, and we have one at 1/3. So I'm going to do this and put 1/3 right here. My y-intercept, still, we can go all the way back to the beginning and look at our constant, which was -2. So that is our y-intercept. So I'm going to go back here. 1, 2, plot that point. Okay, is this an even or odd function? Let's see. It is an even function. The power is 4, which means that they're going to be going in the same direction. And since the leading coefficient is 1, it means they're both going up. So let's draw this. The only one we have to really pay attention to or do something really special with is this double root. So as we graph it at -1, I'm going to bounce off. So I get to -1, boom, bouncing off, going up through there. There we go. That's our graph. Okay. So that is how you graph these rational roots. So a lot of the time it's just guessing. Like to figure out which root to use, a lot of times just guessing. My first guesses is always going to be 1 and -1 because it's easy to do. So keep that in mind. All right, so here we go. find all those zeros of this possible or this function. So let's do that. So we're going to do a possible rational roots for our constant is 8. 8 has a couple, so we got plus or minus 1. We got 2 and 4, right? So plus or minus 2, plus or minus 4, and then plus or minus 8. Luckily, our coefficient in front of the leading one is just 1, so it's just plus or minus 1. So we gotta solve this one. So let's start trying some numbers. I'm gonna just try out here. We're gonna just say -1. Now, a way that you could kind of see if it works is think of plugging in -1. Maybe if this is a root, what should our answer yield us? We should get to 0, right? So let's see if that works. So we got -1 to the power of 4. We got -1 to the power of 3. And then we got -8 times -1 to the power of 2. And then we got 8. Okay. So when we multiply all these out, we're going to have 1 minus 1. This is going to be +1, so -8 plus 8. And in the end, when you add all those up, you get 0. So that means -1 is a root. It is what we're looking for. So if you can do this in your head quickly, it might be worth to just start trying to plug in numbers up here to see if it's one of our roots. But regardless, we still have to divide by that root. So let's do that. So I got -1, and I'm going to do this. So 1, 1, -8, 0, because it's missing, right? There's no x term there, and 8. So let's do it. So 1, -1, 0, 0, -8, +8. So we have 8 here, and then -8, and we get 0. Cool. So again, just verification, that works. So we're going to have f of x is equal to, we're going to use this guy to come up with our first factor. It's going to be x plus 1. And then we write out the rest of our factors. So we divided it by an x, so it's going to be x to the power of 3 plus 0x squared. We're not going to put that, minus 8x plus 8. And now we need to figure this out for the, we need to simplify this as much as we can. So doing that is a little bit more like, we can't like factor it like we were able to in like in 2 problems ago. So we gotta do synthetic division again. So what do you guys think I could plug in into this to make, you know, it all cancel out? Well, I don't think 1 will work. So if I plug in 1, I'll have 1 minus 8 plus 8, which doesn't work. So let's try a different number. Let's try 2. So I'll try 2. I'll do it over here. So I'm going to take 2, and I'm going to try to see if it works into this one. So here we go. I got 1, 0, -8, and +8. Bring down the 1. This is 1. 1 times 2 is 2. 0 plus 2, 2. 2 times 2, 4. This is going to be -4. 2 times -4 is -8. Gives me 0. Hey, look at that. So that works. That is another one of my roots. So I have now x plus 1 and x minus 2 and all this junk. All this junk is x squared plus 2x minus 4. Okay, now let's factor this. So this guy is actually pretty easy to factor, isn't it? So 2 numbers that multiply to get to -4, add to get to 2. Well, actually, that's not easy. I was just thinking, there's no 2 numbers that multiply to get to -4, but add to get to 2, unfortunately. So we're going to have to do we can either do the Pythagorean theorem or we can complete the square. It's really up to you guys what you want to do. I'm going to do the Pythagorean theorem, or sorry, the quadratic formula, not the Pythagorean theorem. That's for geometry. The quadratic formula to find the root of this. So if you remember that, x is equal to negative b plus or minus square root of b squared minus 4ac all over 2a. And I'm just going to plug these into the spots they go. So we got negative 2 plus or minus 2 squared minus 4 times 1 times 4, negative 4 rather, square root of all that, all over 2a, 2 times 1. All right, so we're going to have, let's figure out the determinant. So we're going to have negative 2 plus or minus negative 2 plus or minus 4 plus 16 and over 2. And that's going to give me negative 2 plus or minus square root of 20 over 2. Great. We can simplify this square root of 20 into 2 root 5. And we end up with negative 1, and then just divide, and you end up with negative 1 plus or minus 1 root 5. That's your other root. Yikes, that was a lot. But not that bad. So unfortunately, this one we cannot write as a nicer, like we cannot write this any nicer than it already is because it doesn't factor well. So what we're going to do is we're going to just leave this. This is technically correct, right? This is good. We can't write this any better, but we found these last 2 roots that are going to help us graph. So our roots that we got are negative 1 and 2. So when we go to graph it, negative 1, 2, let's plot those points, negative 1, plot that point. And then up here we got 8 is our intercept, 1, 2, 3. I'm not going to do that. I'm just going to say 8's all the way up here. And then let's convert this to a decimal. So when I convert this to a decimal, it's going to be like, so root 5 is, I think it's 2 point something. Give me a second. Square root of 5 is 2.3 whatever times, or whoops. So negative 1 plus that is going to be 1.23, and then negative 1 minus that. Put -1 minus square root 5. It's going to be negative 3.24. So we're going to just have to estimate. So 1.2 is going to be right about there. 3.4 is going to be like right about here. Is it odd or even? Let's see. It is a even with a positive coefficient. So that means right end's going to be going up. And since it's even, it's the same on the other side. Boom, boom. No multiplicity in the roots. So we're just going to go through all these points. So it's going to go down here, up here, through that point, down here, and then through this point, and then back up. Not the prettiest picture. Should go through that point. There you go. But you get the idea. Okay. So we have one more problem here. Last problem. So this one's going to be a little bit unique. Okay. because when we get down to our answer, we are going to have some non-real roots, and we'll take a look at what that means in a second. So let's figure out the possible rational roots. So all of them are going to be divided by 1, so plus or minus 1. I don't feel like writing that out every time, but we just need to figure out what goes on top. So what are the factors of 36? So the factors of 36 are 1, 2, 3, 4, 6, 9, 12, 18, and 36. Okay. So we could plug these in like till the cows come home, see which ones work. But I already got the magic stuff. I already know that -2 is going to work. Okay. So when I plug that in, or when I use -2 there, 5, 0, -36, do some long division or some synthetic division, 2, -1. It's +2, -7, 14. That's going to be 5. So +9, -18, -18, and then +36. Give me 0. So right now that gives me x plus 2 because of this guy times so to the power 5, so that's to the power 4, so x to the power 4 minus x to the power 3 minus 7x squared plus 9 minus 18. Oh, 9x rather. Now I got to factor this, figure out one of the roots for this. Notice it's kind of gotten a little bit smaller because we don't have here our possible rational roots are 18 and 1 on the bottom, which is the same, but that eliminates this and this from our possibilities. So we have less things to test. I, again, have the fortune of knowing what it is, having done this before. It's going to be -3. So we're going to divide, we're going to synthetic divide by -3 here. I'm going to put a plus sign there for. This is just going to be 9, -18. All right, let's synthetic divide. So we got 1, -3. So this is -4. That is going to be +12. This is 5, -15. It's going to be -6. It's going to be +18. And we got 0. Check that out. It works again. So we can simplify it a little bit more. Our factors are going to be x plus 2 and x plus 3. And let's write out the rest. So it's going to be x to the power of 3 minus 4x squared plus 5x minus 6. Okay, again, what we're going to have to do, we have our factor on top is going to be 6. So we got to think of the roots of 6, which are 1, or our factors of 6, which are 1, 2, 3, 6. And then on bottom is just going to be 1. So we got to go through those, guess which one would work. I'm thinking that 3 would work if I plugged it in here. So I'm going to try 3. So I got 1, -4, 5, and -6. So I'm going to take 1, bring that down. 1 times 3 is 3. It's going to be -1, 3 times 1, -3. That times that's 2. This times this is 6. That gives me 0. So in the end, we will have, let me write it out. So we have 3 factors so far. So we have x plus 2 from the very beginning. We have x plus 3 from the second time we did it. Now, oh, that's not a 3. X plus 3, and then that's going to be x minus 3. And then all this. So x squared minus x plus 2. Woo, man. Now this, unfortunately, we are not able to actually solve this. We're not able to actually get an answer here. If we were to use a quadratic formula, we would have positive 1 plus or minus the square root of negative 1 squared minus 4a, which is 1, times c, which is 2, all over 2 times 1. So look what happens here. So we'll have 1 plus or minus. Here it's going to be 1 minus 8, which is negative 7, over, and then all this over 2. What is wrong with this? Why does this not work? Well, you'll notice here we have a negative inside of our square root, which is never good. So what this means is that this is going to be an imaginary root. Okay, so I can change this. I'll make it into 1 plus or minus I root 7 over 2. So here we have, so we do indeed have 5 roots, okay? We have x is equal to negative 2 is one of our roots. X is equal to negative 3 is one of our roots. X is equal to 3 is one of our roots. And then we have our 2 imaginary roots here. So we have 1 plus I root 7 over 2 and the negative version of it, so plus or minus. So this still holds up, even though this is to the power of 5. It still is going to have 5 roots, okay? But 2 of those roots are imaginary. Okay, it's the positive of this, the plus of this, and the minus of this. Okay. I don't know why I put this extra one here. I'm going to erase that. Okay. So all of these are our answers. Lastly, let's draw it out here. So we're just going to do a quick sketch. Our y-intercept, if we go all the way back up, is negative 36. So I'm just going to put a point down here, call this negative 36. And the only ones we're going to plot are the real ones. So we're going to have negative 3 is one of them, negative 2 is one of them, and then negative 3 is one of them. Positive coefficient, so it's going up. It's an odd function, so this side's going down. And we are going to try to do this out. Goes through all these points, bada bing, bada boom. Got all of them. So I know this is a lot. You really have to have the fortitude to do these, and I don't assign that many of these problems in your guys' homework. So please put in the work for these. I know it's a lot, but you guys are fully capable of doing all of this. Okay. I believe in you guys, and good luck on the homework. We'll talk about it in class, I'm sure. Have a good day. Bye.